Okay, this is the video key for tonight's homework for most of them. All right, here we go. For these, I want you to isolate the variable, which means get rid of all these numbers around it first. The way this one's set up, I'm going to have you eliminate this 3 on the bottom. This one, I'm going to have you eliminate that 2. This one, the 3. So the opposite of dividing by 3, multiplying both sides by 3, which will eliminate this 3 and that 3 and just leave me 2x plus 4 in parentheses equals 36. And then right here I distribute 2 times x, 2 times 4 gives me 2x plus 8 equals 36. Subtract 8 on both sides, minus 8 minus 8. And that will give me 2x equals 28. Divide by 2, and that gives me 14. Alright, this problem right here. I want you to do the opposite of timesing by 2, which is dividing both sides by 2. The opposite of timesing by 2, dividing. Divide this whole side by 2, this side by 2. These will cancel, and all it leaves me is this, what's left over, x plus 3 plus 4. I'm going to drop the parentheses. There's nothing for me to distribute. Equals 6. And then take away 4 on both sides. Minus 4 gives me x over 3. Equals 2. The opposite of dividing by 3, multiplying by 3. So that gives me x equals 6. This one, timesing both numbers by 3, timesing by 3 will eliminate these 3's and just leave me this 2x plus 4 equal to 36. Subtract 4 on both sides, minus 4 minus 4 gives me 2x equals 32. And then divide by 2 right there. And that gives me x equals 16. All these answers will work if you plug it back in. If I plug in 14 right here, that would give me 14 plus 4, which is 18, times 2 is 36, divided by 3, 12. Perfect. If I plugged in 6 right here, 6 divided by 3, 2. 2 plus 4, 6. 6 times 2, 12. That where answer works. 16 right here. 2 times 16 is 32. Plus 4 equals 36. Divided by 3 equals 12. Alright, keep going. I'm going to do 3 of these graphing ones on this page. The rest, I have faith in you guys' ability. So on this, to graph, the first number tells me where to put my first point. The next number in front of x tells me where to go. So this one starts at -2 down the y-axis. 5 made into a slope fraction is 5 over 1, which means from this -2, right 1, up 5. Right 1, up 5. Staircase the other way. Left 1, down 5. Draw your line through it. And then we want you to see if the point 1 for x, 3 for y is on that line. So if I go over 1, up 3, I could clearly see that that point is on that line. That would be a yes. Next one, +8. Go up to 8 on your y-axis. That plane number, the y-intercept, always either up or down this axis line. So up to 8, look at that number in front of x. I'm going to shift that negative to the top, so that -1/2 is -1 over 2, which means every time I go to the right 2, I'm going to go down 1. So starting at 8, right 2, down 1, right 2, down 1. Don't want to go over 1, down 2. Nope, that's -2 slope. Right 2, down 1. Draw your line. Plot the point 0, 7. 0 for x, 7 for y. 1, 2, 3, 4, 5, 6, 7. I could see just below that line. So that would be a no. That point is not on the line, not a solution to the equation. If it's not on the line, it's not a solution to the equation. All right, this one, positive 4 right here. That number in front of x, negative 1. If there's no number there, that negative x is negative 1. Right 1, down 1. So from 4, I go right 1, down 1, right 1, down 1. Staircase the other way, left 1, up 1, left 1, up 1. To see again if that point is a solution, I want to see if that point is on that line. So 2, 2 over 2 up 2, I can clearly see is on that line, which means that point is a solution. Every point on a line is a solution to that line's equation. Every point. This point, 1, 3, plug in 3 for y, 1 for x. 5 minus 2 gives me 3 equals 3. Every other point, this point, which is 2, 8, 1, 2, that point works too. Every point on a line is a solution to that line's equation. Any point not on that line is not a solution. All right, let's keep going. Last page. These ones are seeing if they're equivalent or the same. So for me to tell, I got to do a little bit of work. I'm going to distribute this negative to make that 14 minus 3a minus 2, and I could clearly see again these are the same, they are equivalent, which means these two expressions, even though they look different, the original ones here, they are equivalent. That one is equivalent to that, even though they look different. Doing that little bit of work proves that they're exactly the same. All right, this one, to see if these two expressions look different but are the same, equivalent, distribute this 4b, minus 2 times 5, 10. Again, I could see when I do that step, they are equal, which shows these two original expressions are equivalent. Different looking, but truly equal in every way. All right, for this, I'm going to do a split. I'm going to divide this x by 4, and then I'm going to divide that 7 by 4. Split it up. And again, that is a yes. That is the same as x minus 4 minus 7 minus 4. That's a split. Divide that both by 4. Which again means this expression is equivalent. Even though they look different, they are the same. This one, 3 times w, 3 times negative 9 gives me 3w minus 27 over 5. If I do that split and divide 3w by its own 5 minus 27 divided by its own 5, you split it up, you can see those are not the same, which means these are not equivalent. This is a big fat no. All right, let's keep going. This one, I'm going to do some work to see if these are the same, which two. So I'm going to take that 4t divided by 2 minus 10 divided by its own little 2. And that gives me 2t minus 5. This problem right here, if I divide 4t by 2, it gives me 2t and leave that minus 10 alone. This is 2t minus 10 already, 4t minus 5. I can see that these are equal, which means out of this set, only this one and this one were equivalent. None of the other ones were equivalent. All right, number 13, I'm sorry. So on 13, again, I'm going to isolate it. I'm going to multiply by 5 first. This one, I'm going to divide by 4 first. This one, I'm going to times by 5 first. So one step, timesing both sides by 5 eliminates that and just leaves me 4 times parentheses x minus 2 equals 20. I'm sorry, 100. 20 times 5. Distribute that 4 to get 4x minus 8 equals 100. And then shortly I'll show you how to solve these. 14, divide both sides. Don't want to do this. If I distribute that, that gives me 4x over 5 minus 8 equal 20. You'd have to be solving this weird fraction equation by timesing both sides by the reciprocal, 5 over 4. So instead of doing that, I'm going to divide both sides by 4, which will eliminate that and just give me x minus 5, or x divided by 5 minus 2 equals 5. And again, I'll show you how to solve these. For this one, times by 5, times by 5. These will cancel away and just leaves me 4x minus 2 equals 20. I'm going to shrink this down and I'll show you how to solve these. So this first one here, I'm going to add 8 plus 8 plus 8 cancels away. Bring down the 4x equals 108. Divide both sides by 4, and that gives me x equals 27. This problem, add 2 plus 2, bring down the x divided by 5 equals 7 now, and then the opposite of dividing by 5, timesing both sides by 5, timesing by 5. Those will cancel away and just leave me x equals 35. This problem, add 2 plus 2, bring down 4x equals 102. Divide both sides by 4, and that gives me x equals 30. What is that? I'm sorry. X equals 22 and a half. All right, so again, isolate the equation before you start doing your math. Get rid of those fractions. Get rid of that number out front. Get rid of that fraction. Equivalent, the same but look different. Sometimes you got to do a little bit of math to see. All right, last page. These ones, they want you to take these numbers and plug it in and see if it gives me a solution to that equation or two equal numbers. So for this one, where that a used to be, I'm going to plug in -3. I'm going to leave that 4 there. I'm going to leave that plus 3 there and equal -9. This gives me -12 plus 3, and that truly is -9 equals -9, a true statement. Yes. 17. If I plug in 4/3 here, 3/4 times 4/3 plus 1/2 equals 3/2. If I times this straight across, this gives me 12/12, or the same as 1. Or I cross off all those and just get 1. That turns into 1 plus 1/2 equals 3/2. That is true. That is a yes. 1/2 is the same as 2/2. Plus that 1/2 gives me the 3/2. So yes, that is true. All right, 18. Plug in 2 in for y. So that gives me 2.5 times y, which is 2, minus that 10, equal to -1/2, -0.5, -0.5. This 2.5 times 2 gives me 5. 5 minus 10 gives me -5. That is not the same as -0.5. That's a no. For this one, a little bit more difficult. Plug in -5 into both spots for z, right here and over here. That gives me 2 parentheses 5 minus 2 times in parentheses minus 5. I'm going to close that parenthesis up. Mine equals 20 minus 2, and then plug in -5 right here, minus 1. This gives me 2 times 5. This -2 times this -5 gives me positive 10 inside there, equals 20. Minus 2, -5 minus 1 gives me -6 inside there. 2 times 5 plus 10, 15. 20 plus 12, -2 times -6 gives me 30 equals 32. That is a no. All right, 20. Plug in 1/4 into both w places, which gives me 4 times 1/4 equals 1/4 plus 3/4. And I can clearly see this gives me 4/4. And this gives me 4/4. That is a yes, that 1/4 was a solution. Number 21, this is plugging in b into an equation with no b variables. So this is not enough information. This one does not apply. There's no equation for b to plug into. So I'm just going to leave that alone and say not enough information or does not apply, whatever you want to say. Alright, I hope this helps. Good luck.